So this is 4.2a, elementary algebra, division with exponents. Alright, so we did multiplication with exponents in 4.1. Now we're going to do division, and really the main difference is in division you subtract exponents, whereas in multiplication you added the exponent. So if I have an x to the fourth over x cubed, that means x to the 4 minus 3, which equals x. And that's the proper way. Some people will look at this and say, I have 3 x's, I have 4 x's. I'm going to get rid of these 3. I'm going to get rid of 3 out of these 4, and I'm left with 1. And that's where I come up with that for an answer. So, you know, either way is going to work. You'll get to the point where you have x to the fourth over x to the sixth. And what does that mean? That means x to the 4 minus 6, or x to the negative 2. Or again, if you want to do it the other way, I have 4 there, I'm going to take 4 away from there, and I have x squared. So this, when the numerator goes away completely, there's always a 1. So I have 1 over x squared. This and that are the same. Notice the negative on the exponent right here. That negative means one thing. Well, for one thing, it means it doesn't mean negative, but what it means is that this number or letter and this number or letter are in the wrong place. We have a fraction, and this is written as x over 1. Well, I'm saying that that negative sign means that the x and the 2 are in the wrong place. That negative means they should be in the denominator instead of the numerator, and then the negative can go away once they're in the right place. So, therefore, these two are equal to each other. Okay, so again, the negative sign means that the number here and the number here are in the wrong place, and they need to go to the bottom. It does not mean that the bottom goes to the top. Okay, it just happened to be that we took this whole thing from up here and moved it down there, leaving nothing there, and you cannot have nothing in the numerator, so you put a 1 there. But, for example, if I have 2 to the negative 3 over 4, what's in the wrong place? The 2 and the negative 3 are in the wrong place, so I'm going to put them down here. But I did not move the 4. The 4 doesn't have a negative exponent there. It has nothing, so it's in the right place. But because I took it, it has to be a 1 up there. So that's 1 over 4 times 2 cubed is 8, which is 1 over 32. So remember, this does not flip upside down. If there are no negatives on numbers or letters, they don't move. They stay where they're at. Alright, so I don't remember if we've already gone over this in past lessons. The book seems to allude that they have, but if we have, great. If we haven't, then we'll keep practicing these. So if we have 5 to the negative 2, that means 5 to the negative 2 over 1, which means my 5 and 2 are in the wrong place because there's a negative sign, and when I take it out of the numerator there's nothing left, so I put a 1 up there, so that's 1 over 25. Okay, if I have 3x to the negative 6, okay, again, my 3 is in the right place, so it doesn't move. It's my x to the 6 that's in the wrong place, so that goes down on the bottom. Okay, so again, just to remind you, when you're dividing, the base numbers, these two have to be the same. They have to be the same letter or number. And then we write this as 2 to the top minus the bottom. Okay, and that is an answer. Or if they want it with a positive exponent, we take the 2 cubed and move it to the bottom where it should go, and because the negative says it doesn't belong in the numerator position, so then that gives me 1 over 8. So examples 4, 5, and 6 are pretty self-explanatory. We get down to property 5 for exponents. Let's look at the examples 7, 8, and 9 for that. We have x over 2, and we're cubing that. And that cube means that we're cubing the x, and we're cubing the 2. So that's going to be x cubed over 8. Okay? So if I have 5 over y, and I'm squaring those, that's going to be 5 squared over y squared, or 25 over y squared. Crummy looking 2 there. If I have 2/3, and I'm taking it to the 4th power, that's 2 to the 4th over 3 to the 4th, which is 16 over 81. And if you can reduce it, reduce it. In this case, you can't. Next section is called 0 and 1 as exponents. Alright, so knowing all of that information, if we have any number at all or letters and we have an exponent of 0, the answer to that will always, always, always be 1. I could explain why that is true. Usually students don't care why it is true, but let's go ahead and look at it. Let's say we have 3 over 2, or 3 squared over 3 squared. What does that mean? That means numerator minus denominator equals 3 to the 2 minus 2 is 0. Alright, what is any number over itself? Any number over itself is 1. So therefore, it's equal to 3 to the 0 power and 1, and if that's the case, those two are equal. So that's where it comes from. Anytime we have an exponent of 1, the answer is always the base number itself. So let's look if we have something like a number with an exponent of 1 and a number with an exponent of 0. What do we end up getting for an answer there? Well, let's look at 4 to the 0 plus 4 to the first power. That right there turns into a 1. 4 to the first power is 4, and we get 5. Okay, so anything to the 0 power, even if it looks as weird as this, the outermost exponent is 0, so your answer is 1. Okay?